Hello, good evening. Today we are going to talk about what is VHDC with my partner. Her name is Paula and my name is Sebastian. What is it? High voltage direct current HVDC power system use DC for transmission of bulk power over long distance. For long distance power transmission, HVDC lines are less expensive and losses are less as compared to AC transmission. It interconnect the networks that have different frequencies and characteristics.
In AC transmission, alternative waves of voltage and current travels in the line which change its direction every millisecond, due to which losses occur in the front of her. Unlike AC lines, the voltage and current waves don't change their direction in DC. HVDC lines increase the efficiency of transmission lines due to which power is rapidly transferred. HVDC history between the end of the 1880 and the beginning of the 1890 in what is known as the War of the Currents. The stronghold was fought in the United States between two famous scientists. Toronto two scientists took the market for the production and distribution of electrical energy in the country, a growing market at the time. The two inventors who converted in this war were the well-known Thomas Alva Edison and Nikola Tesla.
Initially, the systems were developed in their current. Thomas Alva Edison made a DC power distribution empire and generate consumer element to use the network. This empire was protected by patents, but George Westinghouse had an entrepreneurial attitude and decided to enter the market at any cost. So George Westinghouse financed the idea of Nikola Tesla and created an alternating current company. Thomas Edison had a great difficulty, which was to raise the voltage. Since the voltage that was generated was the one that was finally consumed, while alternating current allowed the use of transformers and to raise a voltage value to transmit a fair distance.
And the Chicago Fair was decided since it was necessary to eliminate the fair, but with the company of Thomas, this business was more expensive than with the company of Westinghouse, and that reason it began to develop with more force the alternative current.
How does a HVDC transmission system works? In generating substation, AC power is generated, which can be converted into DC by using rectifier in HVDC substation, or converting substation rectifiers and inverters are placed at both ends of the line. The rectifier terminal change to the AC to DC, while invert terminal convert DC to AC.
The DC is following with the overhead lines, and at the user end, again DC is converted into AC by using inverters, which are placed in converted substation. The power remains the same at the setting and receiving ends of the line. DC is transmitted over long distance because it decreases the losses and improves the efficiency. A system having more than two converter stations and one transmission line is called a two-terminal DC system or a point-to-point system. Similarly, if substation has more than two converter stations and interconnecting DC terminal lines, it is called a multi-terminal DC substation.
Okay. HVDC transmission network component. The main components of HVDC system are mentioned below: converting station, converting units, converting valves, converting TFEs, a high frequency filters, power source, and leveling reactors and pole.
Converting station. At the substation, rectifier terminal converts an AC to DC, whereas inverter substation converter DC to AC. Every terminal is designed in such a way that they work in the both modes, rectifier and inverter. So then each terminal is known as converter terminal, and a two-terminal HVDC transmission system is having two terminals and one HVDC line. The following figure is showing a typical HVDC converting station.
Conversion unit. As we all haven't already discussed, the conversion unit converts AC to DC, and vice versa is used the three-phase bridge converts. These circuits, also known as gate circuits in HVDC transmissions, and 12 pulse bridge convert in use, which is obtained by connecting 2 or 6 bridge convert, and show in the figure the semiconductor are activated by pulse in the three-phase bridge shown, and the sequence of pulse is T1, T2, T3, T4, T5, and T6.
Converting volts. However, new HVDC converters use 12 pulse converts units and the total number of bulbs in each group showing the figure. Three-stores-based modules are used to make series connection bulbs. The amount of three-stores bulb depends upon the required voltage across the bulb. Filters. Filtration of harmonics is exceptionally essential and furthermore for generation of receptive power at line cumulate converter station. The AC and DC sound music is infused into AC and DC lines separately. The music has the accompanying focal points. Filtration is almost obligatory for generation of reactive power at the range expanding converter station.
Power source reactive. Transformer needs reactive power to produce a magnetic field in electric machines. Part of the input energy is reactive power. Reactive power is consumed to create maintain the magnetic flux. However, it lets decrease in power factor. They achieve a high power factor capacitor are often connected across the device to supply reactive power.
In addition, the active power generates angry losses, converting the system to a glass of beer. The active power is the amount of liquid inside the glass. However, it always generates foam that occupies a volume inside the glass. That foam is equal to the reactive power. Since it is a part of energy that does not produce any work, but is a loss in the process.
Leveling reactors. The smoothing reactor, like as all collect reactor stuff with high introduced oil, the convert is associated with this reactor just before DC. It can be situated at impartial of the line side. The principal motivation behind smoothing reactors. The first, the sweet in the direct current. The second, the diminish the symphony's voltage occurred in the DC lines.
Third, they constrain the plane current in the DC line. Fourth, consequent compensation disappointments in inverters are avoided by smoothing reactors by releasing the rate of ascending of the DC line in the scaffold with the direct voltage of another arrangement associated voltage breakdown. And five, some smoothing reactors diminish the steepness of voltage and current source from the DC line. In this way, the weights of the converted bulb and bulb source diverse are fixed rates.
HVDC system pole. This is the part of HVDC transmission system that contains all HVDC subtension equipment. It also used for interconnection of transmission lines in some normal operation. It is having direct forward polarity relative to the groove. Therefore, the pole refers to the DC, but that has the same polarity concern there.
DC to DC converter. It is called DC-DC converter, a power converter that is able to raise the DC voltage, unlike in the time of the current wars. There are already ways to convert DC-DC. This is possible thanks to the magnetic field strong device, inductors, or electrical field strong capacitors. It is very important, this type of converter, to adjust the voltage, and it is important to regulate and adjust this variable for various applications, starting with the voltage for which the devices are designed in the hub.
For example, in the boost convert is when the operating of the transistor is made the diode conduct leveling RLC circuits. Once the transistor return to conduction circuit is decoupled, the diode behaves as an open switch, and you must select a capacitor base layer to prevent the loss of voltage is not so great while they are decoupled. Meanwhile, the inductor begin to charge.
The medium of transmission. For the year 1954 in Sweden was made the first commercial line in HVDC. This allowed to carry power from mainland Sweden to Gotland. On the island Gotland was made the first link of high voltage direct current. For that time, we are talking about a voltage around 30 kilovoltage, which at this time is not much, but at that time, instead of doing it with a three-phase system in which you would need at least 3 wires.
The transmission was made by a single cable, thus being more economical. Also, the AC transmission is invasive because it uses a tower, and the higher the tension rises, there must be great separation within the cables, and that generate more cost. For DC, the most economical way is to use the sea and lands as a return. What is done is to create a voltage with respect to land. Use the land for the current to return to the sea.
The installation cost of the HVDC system system is higher than that of the HVAC transmission system. Since natural the voltage or current can only be increased or reduced by means of power transformers. In addition, in HVDC transmission, we have HVAC power transformers at the end of the line. Then there is the converter station that converts the intensified AC power into DC power. This power is transmitted over transmission lines, and at the end there is an inverter station that converts the DC power to AC power. What really increases the cost of HVDC installation are the converter and inverter station compared to HVAC.
To have a better understanding of this, let's look at the graph. As you can see, the cost of HVAC and HVDC transmission varies with respect to the transmission distance, showing in the graph to the break-even point. The cost of the HVAC transmission line is cheaper than the HVDC, but after this equilibrium point, the HVAC increases. Since it's necessary to correct an inefficiency of the transmission system generated by the create power that is only generated in the alternating current, and the compensate for these capacitor banks and reactor banks are used that approximately every 50 or 40 kilometers, rectifying the voltage, while in the HVDC this doesn't now occur because there is only reactive power on the produce the work.
Types of HVDC links. Generally, there are three kinds of HVDC frameworks: the determination of every structure in the arranged stage rails upon the operational prerequisites, the adaptability of the demand, the issue of consistent quality and the cost. The most well-known HVDC design graphs are as per the following: a monopolar link, bipolar link, and homopolar link, long-distance transmission, and back-to-back transmission.
Advantage of HVDC over AC transmission. The first point is to AC frameworks having distance frequencies can be interconnected utilizing HVDC transmission lines. This is conceivable in HVAC transmission framework. The second, installation cost is less because of just to conduction and little towers required to HVDC. The third is HVDC utilizes electronic converts, so protections, plane freedom can be actualized higher than HVAC.
The next is in the instance of issues, control level on HVDC framework can be controlled electronically. Two AC framework having distance frequencies can be interconnected utilizing HVDC transformation lines. This isn't conceivable in HVAC transmission framework. And installation cost is less because of just two conductors and little towers required for HVDC. And HVDC utilizes electronic converters, so protections, plane freedom can be actualized quicker than HVAC. Thus, the AC transmission framework has translating its deadlines.
HVDC technology in the electric industries. And the question is regularly asked in matter of when should HVDC transmission be a big over an AC framework before tradition, where that HVDC was shows when transmitting first submerged interconnecting to AC arranged in a non-current manner, and HVDC frameworks remain the best separating and naturally benevolent choice for the avoid customary application.
And why choose HVDC over HVAC? HVDC transmission is most helpful, especially for the interconnecting of different frequencies. AC grids also provide high efficiency and control capacity. It can be our choice that we go for HVDC power transmission system because the C can able to carry a significant amount of electricity with shovel losses. Another problem with AC is that most of the renewable generation, like solar, hydro, and other plants located at populated centers, and our choice should be DC for electricity transmission at that places. HVDC is necessary or desirable from technical point of view.